exams of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers. You must download our app for a better preparation of your exams. Students, today I'll be solving JEE Mains 2024, 27 Jan. Shift 2 paper. I'll be solving the mathematical part of this particular paper in the video. So, very best of luck. Here we go with the question number 1. It says, considering only principal values of inverse trigonometric functions, the number of positive real values of x satisfying this equation is. So let's write down the equation. You have tangent inverse x, tangent inverse 2x is equal to pi by 4, or I'll say tangent inverse 2x pi by 4 minus tangent inverse x. Let's take tangent on both the sides. On both sides, you will have 2x is equal to tangent of pi by 4 minus this. So, tan this is a and b, tangent a minus b is given by tangent a minus tangent b divided by 1 plus tangent a into tangent b. This is 1 minus x upon 1 plus x. That's equal to 2x. So let's do the cross multiplication. Pretty easy question actually, right? 2x plus 2x squared is equal to 1 minus x. So you have 2x squared plus 3x minus 1 is equal to 0. Applying the quadratic formula, you have x is equal to minus 3 plus minus b squared, which is 9 minus 4ac. This will be 8, right, upon 2a, which is b square minus 4ac plus minus b, this upon 2a. So this will be equal to 4. It is plus over here because minus 4 is here, right? So this will be equal to minus 3 plus minus root 17 upon 4. So the only possible value of x over here, the number of positive real values of x satisfying this equation is, so only possible value of x is minus 3 plus root 17 upon 4. I can't take the negative value because in the question they have asked positive real values of x. Okay, so that means one possible value. Option B is the correct answer. Hope you are clear with this. Next is question number 2. Consider the function f0 to 2 belongs to real numbers such that fx is defined by this and gx is defined by minimum of ft for t belonging to 0 to x and x lies between 0 and 1. And it's given by this function for x lies between 1 and 2. Then which of the following is true about the gx function? Okay. So, all right. See, one thing, if I'm considering the function fx, the function fx was equal to x by 2 by x. If I want to know the nature of the function decreasing or increasing, so let's find out the derivative. This will be 1 by 2 minus 2 upon x squared. Therefore, this is decreasing in the domain. Fx is always these type of sums. If you take them in graph, it takes so less time and they are easy to do. So fx is a decreasing function in the domain like this. Right? If I'm taking x is equal to 0, it will never touch this line because that will mean infinity, and you have this function. Okay, when I'm putting x is equal to 2, when I'm putting x is equal to 8, when I'm putting x is equal to 2, you'll have the corresponding y value as 2 also. Let's check. When you put x is equal to 2, this will be 2 by 2 plus 2 by 2, which is equal to 2 only. Okay. So this is a decreasing function. This is your x's, y, and x. This is 2. This is 2. Now, you are given the function gx. This is the minimum of fx, that is x by 2 plus 2 by x for x lying between 0 and 1. And this is given by 3 by 2 plus x for x lying between 1 and 2. Now, this function, let's check out the nature of this. This is the same one. This will have the same graph as this. Till 1. So let's make the graph. Very bad in drawing actually. So this is till 1 and here is till 2. This is, let's say, 2 over here. So this is the 2 and let's say this is 5 by 2. Now, for this function, for this graph, if I'm putting x is equal to 1, so this will give me x is equal to 1. This will be 1 by 2 plus 2. So this will be 2.5, or this will be equal to 5 by 2. So for 5 by 2, when I'm putting x is equal to 1, it will have this value. Let's how to make it. This graph will something go like this. Wait, I'll remake this one. Okay, now again, for x is equal to 1, your fx will be equal to 1 by 2 plus 2, which is equal to 5 by 2. So now let's come over here. This is 2, and let's say over here you have somewhere 5 by 2. Now this graph will be decreasing till 1 because I have to reach till 1. So till 1, it is a decreasing graph like this. Okay. Now after that, it will have 3 by 2x. Now it is a straight line after that. It goes like this till 2. Okay, let's make it. So till 2 like this. Or less than 2, it's a straight line. Now this is, see, if I'm seeing this is the graph for gx and that was the graph for the previous one was the graph for fx. This is a continuous graph. Of course, this is a continuous graph. And this is continuous, but it is not differentiable at x is equal to 1. Look over here. This is continuous graph, but this is not differentiable because the curve takes a turn from here like this. The slopes are not the same at this particular point at x is equal to 1. Therefore, this is not differentiable. That makes option A is equal to the right answer. Hope you're clear. Next is question number 3. Let the image of the point 107 in this line be this point alpha, beta, gamma. Let's make this figure first. So you're having the point given as, let's say this is the point 107. Here is the line. X by 1 is equal to y minus 1 upon 2, z minus 2 upon 3. So this is the point, and you're having a mirror image, let's say this is the mirror M, this is the point, and this is Q is the image you are given in the question. This is alpha, beta, and gamma. From here, since M lies on this line, so M will have this, the coordinates will be one, let's say this is equal to lambda. So this will be equal to lambda and 2 lambda plus 1, 3 lambda plus 2. Okay, and next, then which of the following point lies on the line alpha, beta, gamma, making angle this and this with y and z axis. So actually you're given the direction cosines m and n over here and an acute angle with the x axis. Okay, first of all, I need to find out the alpha, beta, gamma. Let's go for this. So you are having m as this and P, the point was 107. If I want to find out the PM vector, this will be given by lambda minus 1 I cap 1 plus 2 lambda J 3 this minus 5 K. Okay, this is your PM vector. Now this PM vector, this is perpendicular to the given line, this one. It's given that the image of this point, this, and which of the following, yeah, it is perpendicular to this line. So let's say this is the line with the direction, with the vector B. According to this, it will be given by the vector I plus 2J plus 3K. This will be the vector for this line, L1. Now PM is perpendicular to B vector. So that means their dot product will be equal to 0 because the cos 90 is equal to 0. So you have a PM as lambda minus 1 I cap 1 2 lambda plus 1 j cap, 3 lambda minus 5 k cap. The dot product of this with the vector I 2j plus 3k is equal to 0. Let's find out the dot product. This will be lambda minus 1 plus 2 into 2 lambda plus 1 plus 3 into 3 lambda minus 5 is equal to 0. Lambda minus 1 plus 4 lambda plus 2 plus 9 lambda minus 15 is equal to 0. You have 14 lambda is equal to, this will be plus 1 and 14. You will have lambda as 1. What will therefore the m will have the coordinates as 1, 3 and 5. See, m has lambda 1 plus 2 lambda 2 plus 3 lambda. So these are the coordinates of the point M. Now, if I talk about the point Q, this is equal to twice of M minus P because M is the midpoint on PQ. Now, Q vector will be twice of M vector minus P vector because M vector is midpoint on P and Q vector. So you will have Q vector as twice of M. M was given as this. So this is I plus 3j plus 5k and P was, what was P? That was 107, right? So this is minus 1, 0 and 7. So this makes it 2I minus I plus 6j minus 0 plus 10k minus 7k. So I plus 6j plus 3k. Okay, this is your Q vector. That means Q is having the coordinates as alpha, beta, gamma. So alpha, beta, gamma, this will be 1, 6 and 3. Okay, now the required line. Now let's move to the gamma. I have already solved this alpha, beta, gamma. This comes out to be 1, 6 and 3. Now the second part, which are the following points will lie on alpha, beta, gamma, making angles this and this with the y and z axis. Now you know about the direction cosines. L square plus m square plus n square, that is equal to 1. I don't know about L square, but I'm given m square, that is equal to cos of this angle, and n square is cos of this angle. So cos of it was 2 pi by 3, I think, and cos of 2 pi by 3, 3 pi by 4. 3 pi by 4. This will be cos of 120, which is equal to cos of 180 minus 60, or this will be minus cos 60, which will be equal to minus 1 by 2. And this will be equal to cos 135, or this will be cos minus cos 45, or minus 1 by root 2. So here will be this square plus this square is equal to 1, L square plus 1 by 4, 1 by 2 is equal to 1, or L square 1 minus 1 by 4 minus this, you will have 4 minus 2, no, 4 minus 1 minus 2 upon 4. That will be equal to 1 by 4. That was L square. So L will be equal to 1 by 2 because line is making, it's given in the question, line is making acute angle with x-axis. That means lying in the first quadrant. So L will be equal to positive 1 by 2. Okay. Now equation, what you had to find out was, okay, which of the following point lies on this? For that, let's find out the equation. Equation on line passing through 163, it will be given by R is equal to I plus 6j 3k plus mu 1 by 2 I cap minus 1 by 2 j cap minus 1 by root 2 k cap. Now you have to check which of these points. You are given 1, 2, 3, 4 choices. You have to find out for different values of mu which point will be satisfied. And you will check that option 3 satisfies the given equation, the equation we have just solved for mu is equal to 4. If I put mu is equal to 4, if I put this mu is equal to 4, option 3 will satisfy this given equation. All right. So hope you are clear with this, and option C becomes the right answer. Next is question number 4. Question number 4. Let R be the interior region between these two lines containing the origin. The set of all values of A for which this point lies inside R is. So let's understand. First of all, you are having, this is the coordinate axis. This is your origin, right? First equation, L1. L1 will have something like this. This is your L1 equation given as 3x minus y plus 1 is equal to 0. And this is your second one. L2. This is the second equation of the line. Okay. X and y axis. Now in the question, this is the interior region. This is your origin, and this is your interior region, which contains your what is that? Let R be the interior region between these two lines containing the origin. Okay. Now you have to find out all the set of values of A for which these points will lie inside this given region. Okay. Fine. So first line you are having, let's say this is the pointer P, A square and A plus 1. And you are having first line equation as 3x minus y plus 1 is equal to 0. You are given in the question that origin and this P should lie inside. Origin and P lies on same side with respect to L1. Right? So that means L1 0 and L1P, the dot product of them is greater than 0. So this is, this gives me 3A square minus A plus 1 plus 1. It should be greater than 0, right? So this gives me 3A square minus A should be greater than 0. Or you have A, 3A minus 1 greater than 0. So that means A will belong to minus infinity to 0 union 1 by 3, because here A will be greater than 0, or for this to be greater than 0, then both should be, or A should be greater than 1 by 3. Okay. And this will be the one. A should be less than 0. Wait. Say this is equation 1. Now for the line L2, you have the equation of L2 as x plus 2y minus 5 is equal to 0. Now for origin and P lie on same side with respect to L2. You should have L2 0 into this should be greater than 0. So you will have again A square plus 2A plus 1 minus 5 less than 0, or A square plus 2A minus 3 less than 0. You will factorize, you will get the two factors as this. So here the range of A will be A belongs to minus 3 and 1. Let's say this is 1 and 2. Now combining these both ones, this and this equation. This range is actually A will belong to minus 3, 0 union 1 by 3 to 1. So this is the answer to the question. Let's check out. You have option B as the right answer. Hope you're clear with this. Next is question number 5. The 20th term from the end of the progression, this is given by. See, whenever you have to find out the term starting from the end, like you have to find out the 20th term from the end, what you do is you always reverse the series. So now this series will be given by minus 129, 1 by 4, so on till this and this. So now this becomes your first term, right? A is equal to minus 129, 1 upon 4. And what will be D? It will be the difference between the two terms, that is 20 minus 19, 1 by 4, which is equal to 3 by 4. So this is your first term. This is your common difference. T20 will be given by A plus 20 minus 1 into T. Or this is minus 129, 1 by 4 plus 19 into 3 by 4. This is equal to minus 157 upon this plus 19, 3s are 57 upon 4. Or this will be 460 minus upon 4. Or this will be minus 1 by 5. That makes the C option. Very easy question this was. That makes the C option to be the correct answer. Next is question number 6. Let f be the function which has all the real numbers except minus 1 by 2 and g has all the real numbers except minus 5 by 2. Be defined as fx as this and gx as this. Then the domain of f of g is. All right, let's write down. You have the two function. First, fx is this function for all x except minus 1 by 2 and gx be this function mod x plus 1 to x plus 5 for all x except minus 5 by 2. So what do you have to find out? Domain of f of gx, right? So f of g of x is equal to 2g of x plus 3 2g of x plus 1. So one thing, x is not equal to minus 5 by 2 and mod x plus 1. This should not be equal to minus 1 by 2. That means x belongs to all real numbers except minus 5 by 2 and it belongs to all real numbers also. So domain will be given by all real numbers except minus 5 by 2. So that makes option A. Question number 7, for a line between 0 and 1, you have to find out the integral value for this function. Let's say this function is equal to I. And let's say this is equation 1. So you have I as this limit 0 to pi dx upon 1 minus 2a cos x plus a square. I'll do one thing. You know the King's rule. It's states that the integral of limit 0 to b fx dx is equal to integral limit 0 to b f of a plus b minus x dx. So I'm applying this over here. This will be equal to 0 to pi dx upon 1 minus 2a cos 0 plus pi minus x plus a square. So this will be limit 0 to pi dx upon 1 minus cos pi minus x. This will be, see, pi will let the cos be only cos and pi minus x, it lies in the second quadrant. So this is minus x plus a square. This will be equal to integral 0 to pi dx upon 1 plus 2a cos x plus a square. Now this was also equal to I. This is I also, we had I as this. Let's write down both of them. So from here you have I as 0 to pi dx upon 1 plus 2a cos x minus, no, plus a square. Also from equation 1, you have I as dx upon 1 minus 2a cos x plus x a square. Adding both of them, you will have 2I is equal to integral 0 to pi dx. Dx I'll write down later. 0 to pi. Let's take the LCM first. 1 plus 2a, or I'll say 1 plus a square. Let's concatenate that. 1 plus a square yeah, plus 2a cos x multiplied by 1 plus a square minus 2a cos x. And here will be 1 minus 2a cos x plus a square plus 1 plus 2a cos x plus a square dx. These two things will cancel out and you will have 2I is equal to integral to 1 plus a square upon this will be 1 plus a square whole square minus 4a square cos square x dx. This 2, I'll take it outside. Integral of, now dividing, okay, what I'll do, I'll divide numerator and the denominator by cos square x. So this will be, I'm taking 2 outside and this will be 1 plus a square into secant square x divided by this will be 1 plus a square whole square into secant square x minus 4a square dx. Now let's put secant square x, this 2 and 2 will cancel, I is equal to, let's put this secant square x as a, one thing, I forgot to put the limits everywhere. Now I'll do one thing more. I'm changing the limits. 0 to pi by 2. I will take 2 outside, right? Now, also doing one thing, I'll put this secant square x as 1 plus tangent square x. So this will be equal to 1 plus a square whole a square secant square x divided by this, and I'll write down this as 1 plus tangent square x minus 4a dx. All right. So this is equal to, I is equal to twice limit 0 to pi by 2, 1 plus a square into secant square x dividing, this will be 1 plus a square whole square plus 1 plus a square whole square into tangent square x minus 4a square. Okay, this is twice limits this 1 plus a square secant square x divided by this will be 1 plus a power 4 plus 2a square. I'm writing minus a 4 square over here plus 1 plus a square whole square tangent square x dx. Hope you're clear till here. So this is twice 0 to pi by 2. Okay, like this. Divided by this will be 1 minus a square whole square plus 1 plus a square whole square tangent square x dividing numerator and denominator by this function. Okay, so this will be twice limit 0 to pi by 2. This will be secant square x upon 1 plus a square divided by this will be 1 minus a square upon 1 plus a square whole square plus tangent square x. Now I'll do one thing. This is a constant. I'll put 1 minus a square upon 1 plus a square as equal to some is equal to some u. This is a constant, right? Because it looks like a bit clumsy. So I'm giving it a simple variable. I'm not worried about the constants over here. Also, let's put tangent x is equal to t. So this is equal to t, that makes secant square x dx is equal to dt. Now, further, this will be equal to, I'm taking 1 plus a square outside, integral limits 0 to pi by 2 secant square x upon u square plus t square. Sorry, secant square x, I'll write it as dt only. Okay. Hope you're clear till here. So now you know one more formula, that is integral of 1 upon t square upon a square dt is equal to 1 upon a tangent inverse t upon a. Okay. And now using that, this is equal to 2 upon 1 plus a square multiply 1 upon u multiply tangent inverse t upon u. The limits are, wait. T upon u, the limits were 0 to pi by 2. Okay, So now, what was your u? U was equal to 1 minus a square upon this. So this is 1 plus a square multiply 1 plus a square upon 1 minus a square, because this is inverse of u and u was this. Okay. Into tangent inverse t. Okay. So tangent inverse pi by 2, this will be, wait, I have done something wrong. I didn't change the limits when I put this t. I have to change the limits also over here. See, when x is approaching 0, t will approach to 0. And when x is approaching pi by 2, t will approach to infinity. So here the limits will be changed to infinity only. Also, the limit will be infinity, and here also it will be pi by 2 minus 0. Okay. When I'm putting tan inverse of infinity, that's equal to pi by 2, and for 0 also it becomes 0. Now this will cancel, and this will be equal to 2 upon 1 minus a square into pi by 2. 2 and 2 will also cancel. So this will be equal to pi upon 1 minus a square. This is the answer to the question, right? Pi upon 1 minus a square, option C stands to be the right answer. Hope you're clear. Next is question number 8. Let gx is equal to this function, and second derivative of fx is greater than 0 for all x belonging from 0 to 3. If g is decreasing in this interval and increasing in this interval, then 8 alpha is equal to. Okay. So let's write down. First of all, you have the gx function is equal to 3fx upon 3 plus f of 3 minus x. You are given in the question that this is second derivative is greater than 0 for all x belonging 0 to 3. That means f dash x is increasing function, right? Yeah, that means this is an increasing function. So let's find its derivative. G dash x, this will be equal to 3 into 1 by 3 into f dash x by 3 minus this function. Also f dash x by 3, let's the dash x is equal to this minus this. Now you're given in the question that this is decreasing and this is increasing in this interval. G is decreasing and increasing in this interval. Let's write down if G is decreasing in 0 to alpha. That means G dash x is less than 0, right? And G dash x, it was this. F dash x by 3 minus f dash 3 minus x is less than 0. That makes f dash x by 3 less than this function. So that means x by 3 is less than this, or x will be less than 9 by 4. So that means alpha here, because it lies in this interval 0 to alpha, that means alpha will be equal to 9 by 4. And what you had to find out was 8 alpha. So 8 into this answer is 18. So this is the right answer to the question. Option C. Hope you're clear. Next is question number 9. Again, limit. So you have this 3 plus 8 alpha sin x, beta cos x, log function upon the tan function is equal to 1 by 3. Then you have to find out 2 alpha minus beta. Let's write down. You have a limit x approaching 0, 3 plus alpha sin x, beta cos x plus log to the base e 1 minus x upon 3 tangent square x is equal to 1 by 3, right? Let's open up, sin x, I'm filling the values and expanding sin x, cos x and log functions. Limits x approaching 0, this will be 3 plus alpha x minus x bar 3 upon 3 factorial, so on, beta 1 minus x square upon 2 factorial, x bar 4 upon 4 factorial, so on, plus this is log 1 minus x. So like 1 will be subtracted. It will be minus x power 2 by 2, x power 3 by 3, and so on. This is equal to 1 by 3. This whole is divided by 3 tangent square x. Okay. Now I'm taking, see, this is as x is approaching 0, so x is having a very small value. I can ignore the higher powers of x. I'm taking the approximate values of x over here. So limit x approaching 0, this will be 3 plus from here beta only, because okay, only this constant is there. Plus I'm taking the x coefficients now, alpha minus 1 into x, plus I'm taking the x square coefficients now. These are the x square coefficients, so on. Upon 3x square, I have taken tangent square x over here. Okay, multiplying the numerator and denominator by x square. Now this is equal to 1 by 3, right? See, this is only constant part. You are having x square in the denominator, so that means this becomes, if I open this up, this will be equal to limit x approaching 0, 3 plus beta upon 3x square, limit plus x approaching 0, 1 minus alpha x upon 3x square, plus limit x approaching 0, this will be minus 1 by 2 minus beta by 2 upon 3. Yeah, x square will cancel. So on, this is equal to 1 by 3. So from this equation, you have 3 plus beta, 0, alpha minus 1, 0, minus 1 by 2, minus beta by 2 upon 3 is equal to 1 by 3. These two will cancel, and you will have minus 1 by 2 minus beta by 2 is equal to 1, or you will have alpha is equal to 1 from here, or beta is equal to minus 3 from here. I got the value and would need to solve this. That's it, right? You want to know 2 alpha minus beta. 2 alpha minus beta. This is 5. So this is the answer, 5. Option C. Hope you are clear with this. Next is question number 10. If alpha and beta are the roots of this equation, 1 minus x minus 1 is equal to 0, and you are having Sn as this, then you have to find out which of the following is true. I'm having basically 3 sums, S12, S10, S12, S11, S10. Here also, and here also, here also. Okay, one thing. You have this equation 1 minus 1 minus x. Let's write it, sorry. X square minus x minus 1 is equal to 0. You are having alpha and beta as a root. So that means alpha square minus alpha minus 1 is equal to 0, or 1 plus alpha is equal to alpha square. Similarly, you have beta square minus beta minus 1 is equal to 0. So you have 1 plus beta is equal to beta square. So now you have Sn is equal to 2023 alpha power n 2024 beta power n. Okay. Let's do this thing. Sn minus 1, Sn minus 2. This will be equal to 2023 alpha power n minus 1 plus 2024 beta power n minus 1, 2023 alpha power n minus 2, 2024 beta power n minus 2. Let's combine both of them. You will have 2023 alpha power n minus 2, 1 plus alpha, 2024 beta power n minus 2, 1 plus beta. Okay. This is equal to Sn minus 1 plus this, right? And you know 1 plus alpha is equal to alpha square, 1 plus beta square is equal to 1 plus beta is equal to beta square. You have 2023 into alpha power n minus 2 alpha square 2024 beta square. Okay. Yeah. So now bases are same, powers will add. You will have 2023 into alpha power n minus 2 plus 2 alpha raised to power n. Similarly, here will be beta raised to power n. So this is what? This is your Sn only, right? That gives you Sn plus 1, Sn minus 1, Sn minus 2. The sum of both of them is equal to Sn. Now, if I put n is equal to 12, that gives me S12 is equal to S11 plus S10. Right now, let's check. This is the right one. Option B. Hope you're clear with this. Let's move to the next question, number 11. Let A and B be the two finite sets with M and N elements respectively. The total number of subsets of A is 56 more than the subsets of B. Then the distance of the point P, M, comma, N from this point is. All right. So first thing, any like you are having A is the set with M elements and B is the set with N elements. A is having M elements, B is having N elements. Now the total number of subsets for this will be 2 power n and for this will be 2 power n. Now, according to question, they have a difference of 56. That gives you, according to question, 2 power m minus 2 power n is equal to 56. I'm taking 2 power n outside. 2 power m minus n minus 1 is equal to 56. Can be written as 8 into 7. This is 2 power 3 into 7. Why? Because I want to have it into 2 power something into something. So this is equal to 2 power 3 into this. That gives you n is equal to 3 and 2 power m minus n minus 1 is equal to 7. That gives you 2 power m minus n is equal to 8, which is equal to 2 power 3. M minus n is equal to 3. N is already 3. That makes n is 3. M is equal to 6. Right? You got m as 6, n as 3. Now, what do you need in the question is you want to find the distance of these 2 points. Easy. Actually, what you needed in the question was only m and n. Finding the distance is just an extension, given an extension to the question, nothing else. So you have to find out the distance between the point 6 comma 3 and what was another point, minus 2 comma minus 3. So the distance is given by root of 6 plus 2 square, 3 plus 3 square, which is equal to 8 square, that is 64, and 6 square, which is 36, it will be 10. Answer to the question is 10, and here you have first option as the correct answer. Hope you're clear. Next is question number 12. The values of alpha for which this determinant is equal to 0 lies in the interval. Pretty easy question for you. All right, let's go. So this is a jackpot. I'm having a 0 over here, so I'll ignore this thing. Basically, this was an easy calculation, no issues. I'll be expanding through the third row. So the very first one, 2 alpha plus 3. So that means I'll be leaving this row, not and this column. So first of all, you will multiply this and then minus this. Okay, let's go. This will be 3 by 2 alpha plus 1 by 3 minus 1 by 3 alpha plus 3 by 2 minus here was 3 1 3 alpha plus 1 multiply alpha plus 1 by 3 minus alpha minus 3 by 2. This will cancel and you will have 2 alpha plus 3 multiply 3 by 2 alpha minus 1 by 3 alpha plus 1 by 2 minus 1 by 2. This will cancel minus 3 alpha plus 1. This will be 1 by 3 minus 3 by 2. Okay. So this is 2 alpha plus 3 Here you will have 6 and 9 minus 2 alpha and minus 3 alpha plus 1. This will be 6. Here will be 2 minus 9. I hope I have done it correct. This is equal to 0. So you have 2 alpha plus 3 multiply 7 alpha upon 6 minus 3. Here was, okay, I'll do minus minus plus. Here was minus 7, right? So this will be 3 alpha plus 1, 7 by 6 is equal to 0. Now let's open this. You will have this will be 7 alpha square upon 3 plus this will be 7 by 2 alpha plus 7 alpha upon 2 plus 7 by 6. Right? So this will be 7 alpha squared upon 3. This will be 7 alpha plus 7 by 6 multiplying, dividing both sides by 7, and let's take the LCM also. No, first of all, let's divide both the sides by 7. That will be easy thing. So you will have 1 by 3 alpha square plus alpha plus 1 by 6 is equal to 0. Let's take the LCM. 6, 2 alpha square, 6 alpha plus 1 is equal to 0. That gives you 2 alpha square, 6 alpha plus 1 is equal to 0. That applying the quadratic formula, you have alpha is minus b plus minus b square, which is 36 minus 4ac, which is 8 upon 4ac. That is right upon 2a, 2a, which is 4. Right. Okay. So this will be minus 6 plus minus. This is 26, I think. No. Sorry, not 30. This is 28. Yes. Upon 4. Minus 6 plus minus, this will be 2 root 7 upon 4, or this is equal to minus 3 plus minus root 7 upon 2. So the two values for the alpha will be minus 3 plus root 7 upon 2 and minus 3 minus root 7 upon 2. Root 7 approximately, I'm not telling the exact value, approximately this is equal to 2.5. Right, because it is more than like 2 and less than this. 2.5 square is actually 6.25. So I'm saying exactly not 7, approximately it's near to this. So looking at this, this will be, if I'm putting this approximately, minus alpha is approximately equal to minus 3 minus 2.5 upon 2, which is equal to minus 5.5 upon 2, which is equal to minus 2.75. And from here, alpha is approximately minus 3. Sorry, here was supposed to be plus now. Anyways, I'll write here plus. So this will be this upon this. This will be minus 0.5 upon 2, or this will be minus 0.25. So these are the two values between which the alpha lies. Approximately, again, I'm not getting the exact values. I don't need, because I need to have the interval. So that makes it will lie between minus 3 and 0. Option B stands to be the right answer. Hope you're clear with this. Next is, let's move to the next question, number 13. An urn contains 6 white, 9 black balls. 2 successive draws of 4 balls are made without replacement. The probability that the first draw gives all white, second draw give all the black balls is. Very easy question actually. This is containing your 6 white and 9 black balls. You are having 2 draws, first and second draw. In the first draw, in the both of the draws, 4 balls are withdrawn without replacement. Probability first draw gets all the white balls. So what is the probability that first draw get all the white balls out of 6? See, probability formula, I hope you know. Probability is number of favorable upon total cases. Right? So what are the favorable cases? Out of 6, you get 4 white balls. Let's write it again. Wait. Here was 4. So 6C4, it gives you out of 6 balls, you withdraw 4 white balls. This is your favorable cases. And what are the total cases? Total, how many balls are there? If you add them, you have 15 balls in total. So this is given by 15C4. This is the first draw, like what you want. And in the second draw, you want all the black balls, right? 9 balls, out of 9 black balls, you get 4 black balls. So 9C4 divided by the total. See, in this case, without replacement, that means already 4 balls have been withdrawn. 4 white balls have already been withdrawn in the first case. So how many balls will be left in this case? 15 minus 4, C4, right? Which will be equal to 9C4 divided by 11C4. This is for the first row and this is for the second row. Now, what is the total probability? Total probability is equal to 6C4 upon this multiply 9C4 upon this, right? Let's do this. 6 factorial upon 4 factorial into 2 factorial, 9 factorial, 4 factorial, 5 factorial. Here will be 15 factorial, 4 factorial, 11 factorial. Here will be 11 factorial. Yeah, 11 factorial and 4 and 7 factorial. This will cancel. This will cancel. And what else will cancel? Nothing as such. Okay, let's write it then. So here you have 6 into 5 into 4 factorial upon this into 2. Multiply. Let it be 9 factorial only. And let this be 5 into 4 factorial into 4 factorial upon 15. I think I have to open 15 also. Wait one thing. Yeah, okay. Yeah. So this will be 15 into 14 into 13 into 12 into 11 into 10 into 9 factorial multiplied by 7 factorial. Okay. Now this 9 and this 9 factorial will cancel. This 4 and this 4 factorial will cancel. This 4 and this will cancel. Further, this will cancel at 3. And then you have this cancel 5. And you have a 7 factorial over here. Let's open up this also. This is equal to 3 into 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 15 into 14, 13, 12, 11, 10. I think everything at rest has been cut, right? Okay. So this is 5, 3, 15 will be gone. And 4, 3, 12 will be gone. 7, 2, 3 will be here. And this will be 5. So this will be equal to 3 upon 13 into 55, which will be equal to 3 upon 715. So this is the answer to the question, 3 upon 715, option C. Hope you're clear with this. Let's move to the next question then. Question number 14, you have to find out the integral value for this function. Let's say this function is equal to I. So very first thing, I'll put this function tangent inverse x cube plus 1 upon x cube as t. So this will be equal to, let's differentiate both sides with respect to t. So you will have this as 1 upon 1 plus x cube plus this into derivative of this function 3x squared minus 3 upon x power 4 dx is equal to dt. So this will be equal to 1 upon 1 plus x power 6 plus 1 upon x power 3 whole square multiply 3x square minus this dx is equal to dt. Or this will be x power 6 upon x power 6 plus this, right? Multiply 3x power 6 minus 3 upon this, right? So this is x power 6. Let's open up. This will be x power 12 plus 1, 2x power 6. 3x power 6 minus 3 upon this dx is equal to dt. Or let's just concatenate the terms. This will be x power 12, 3x power 6 plus 1, 3x power 6 minus 3 upon this dx is equal to dt. Now let's get back to our integral. It was lying alone since so long. Now let's write down it once again. You have integral of x power 8 minus x square divided by x power 12 plus 3x power 6 plus 1 tangent inverse. What is it? X cube plus this dx. Okay. So, yeah. I need a bit more calculations for this part. I'll do this thing. This will cancel at 2. Okay. And I'll take 3 common from here. This will be 3 into x square into x power 6 minus 1 whole divided by x power 12, 3x power 6 plus 1 dx is equal to dt. Okay. Now this will be 3. I'm taking again, I'm letting it be like this. 6 power 8 minus x square upon x power 12, 3x power 6 plus 1 dx is equal to dt. Now it is very clear. See, this is your dt if I'm taking 1 by 3 outside. Okay. Or you can say this is equal to dt upon 3. All right. I'm taking this as outside. This will be dt upon d. That's it. And now it is so easy. Everything which was looking so difficult, now it's super duper easy. 1 by 3 natural log t plus the constant c. Right? So that was your I is equal to 1 by 3. Now let's put the value of t, which was log tangent inverse x cube plus this plus t. C, or this is log tangent inverse x cube plus 1 by x cube raised to power 1 by 3 plus c. So this is the answer to the question number 15. If 2 tangent square theta minus 5 secant theta is equal to 1, this has exactly 7 solutions in the given interval. For the least value of n belonging to the natural numbers, then you have to find out the value for this expression. Okay, first of all, let's write down tangent theta as 1 plus secant square theta. You can write it. Tangent square theta plus 1 is equal to secant square theta. And from here you have this equation minus 1, right? So this will be 2 into secant square theta minus 1 minus 5 secant theta is equal to 1, or 2 secant square theta minus 5 secant theta. Minus 2 minus 1, this will be minus 3 is equal to 0. Let's factorize. You will have 2 secant square theta minus 6 secant theta plus secant theta minus 3 is equal to 0. 2 secant theta, let's take that common. You have secant theta minus 3 plus 1 secant theta minus 3. 2 factors, 2 secant theta plus 1 into secant theta minus 3 is equal to 0. That means secant theta can have two values as minus 2 and 1 by 3. So cos theta minus 1 by 2. Wait. It will be 3 or minus 1 by 2. So that means cos theta will have the values as 1 by 3 and minus 2. Right, now in the question, it said that it lies in this given interval for the least value of the natural numbers and belonging to the natural numbers. That means I cannot take the negative value. So cos theta will be equal to 1 by 3. Now in the question, you are given that for at least 7 solutions, for exactly 7 solutions in the given interval. So for these exactly 7 solutions in this given interval, n will be for 7 solutions in the given interval, n will be equal to what is that? Okay. So from here, n pi by 2 was there, right? From here, n will be equal to 13. So what you have to find out is this expression. Summation k is equal to 1 to n. Summation k is equal to 1 till n. N is 13 in this case, k upon 2k. Let's say this is equal to s. So you have s as equal to 1 by 2 plus 2 upon 2 square, 3 upon 2 cube, 4 upon 2 power 4, so on till 13 upon 2 power 13. Let's multiply both sides by half. So this will be 1 by 2s is equal to 1 by 2 square upon, I'll rewrite this, wait. Multiplying both sides by half, I'll write it below this. There's a reason for that, you will just come to. Plus 2 upon 2 cube, 3 upon 2 power 4, so on. Here you will have 13 upon not 13, 12 upon 2 power 13 minus plus 13 upon this. I have multiplied both sides by 2, 1 by 2. Okay. All right. Now let's do one thing. Let's subtract both of them. So you will have s minus 1 by 2s, which is equal to 1 by 2s. That's equal to 1 by 2. Now minus, 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 minus. So this will be 1 by 2. 2 upon 2 root 2 minus 1 upon 2, sorry, 2 upon 2 square minus 1 upon 2 square. This will be equal to 1 upon 2 square. Similarly, subtracting both of them, you will get 1 upon 2 cube. When you will subtract both of these, you will get this, and so on. When you will subtract both of these, you will get 1 upon 2 power 13 minus 13 upon 2 power 14. Right. Now this is what? This is a GP, where this is your first term, this is your last term, and let's say this is a GP. Your first term is 1 by 2, R is equal to 1 by 2. Okay, so this becomes 1 by 2 S is equal to, that's what is the sum of finite terms of a GP? That is given by A into 1 minus R power n upon 1 minus R. So this is A, that is this, and 1 minus R is equal to 1 by 2. And in this case, this is 13 divided by 1 minus R. Then what you had was a minus, it was this thing, 13 upon 2 power 14, right? So this half and this 1 minus 1 by 2, they will cancel out each other. And you will have 1 by 2 S is equal to 1 minus 1 by this minus 13 upon 2 root 2 raised to power 14. This will be 2. This upon 2 power 13 minus 13 upon 2 power 14. That's equal to 1 by 2s. And from here, you will have S is equal to twice into 2 power 13 minus 1 upon 2 power 13 minus 13 upon 2 power 14. So this is the answer to the question. Let's check with the options. You have a, here is this. Okay, I don't have any. Think I have to solve it further. Let's solve it further. So this will be equal to, I'll take the LCM, 2 power 14, right? And this will be, let's open up this first. This will be 2 power 14 minus 1 upon this minus 13 upon this. Now taking 2 power 14 as the LCM, here will be 2 power 15 minus 1 minus 13. Sorry, there's a small mistake I have done. I have taken this 2 on this side. I have multiplied it with 2, but here also it was supposed to be multiplied. Okay, so let's redo from here. So just ignore this part and this part. Okay, so now this expression becomes S is equal to 2 into 2 power 13 minus 1 upon 2 power 13 minus 13 upon 2 power 13. Right, now it will be 2 power 14 minus 2 upon 2 power 13 minus this. So let's take the LCM. This will be 2 power 13, 2 power 14 minus 2 minus 13. This will be 2 power 14 minus 15 upon this. So this is the answer. 2 power 14 minus 15 upon 2 power 13. That is your option D. Hope you're clear with this. Next is question number 16. The position vectors of the vertices of the triangle. Let's make the triangle first. We have the triangle ABC. You're given the position vectors as this, this, and this. So direction ratios will be given by 2 minus 3, 3 for the B. It will be 2, 2, 3. C will be minus 1, 1, and 3. That's your ABC. Next, let L denote the length of the angle bisector AD of BAC. So this is AD, angle bisector. That means these two angles are equal. Let L denote the length of the angle bisector of AD of this, where D is on the line segment PC, then 2L square is equal to. Okay. Triangle. Let's say AB. What is the length of AB? That will be 2 minus 2, 0 square plus 2 plus 3 square, 3 minus 3 square. This will be equal to 5, and BC will be equal to root of 2 plus 1 square minus 3 minus 1 square, 3 minus 3 square, which will be equal to root of 9 plus 16. Again, that's equal to 5. So that means these two sides are equal. If these two sides are equal, that means this AD, this is nothing. This is the perpendicular bisector of BC. Therefore, since AB is equal to BC, therefore ABC is an isosceles triangle. So therefore, the angle bisector AD, that means AD bisects BC perpendicularly, right? So you have this side is equal to this side. Now it's very easy to find out the coordinates of D. Once I get the coordinates of D, I already have the coordinates of A. What we will do? We'll just find out AD. That's easy. What is that? That AD is your L. It has given in the question that L denotes the length of AD. Okay, now all the concentration should go on finding out D, because now we know one thing. D is midpoint on BC. So what will be the coordinates of D? D will be given by 2 plus minus 1. 2 plus minus 1, that is 2 minus 1 upon 2. Then 2 plus this upon 2. Then 3 plus 3 upon 2. That makes this as 1 by 2, 3 by 2, or 3. So these are the coordinates of D. Now we have already the coordinates of A given 2 minus 3. 3. We have the coordinates of D as 1 by 2, 3 by 2, and 3. Now let's find out the length of AD, that is equal to L. This is given by the root of 2 minus 1 by 2 square minus 3 by 2 square, 3 minus 3 square, which is 0. So here will be, this will be 3 by 2. That means in 9 by 4. And this will give me 6 and 3, 9. So 81 by 4. Okay, plus 0. That is root of 90 by 4, which will be like 4 will be cut. Root of 45 by 2. That's your L. What you had to find out in the question was 2L square. So L is equal to root of this L square will be 45 by 2. 2L square will be equal to 45. That's it. We needed that answer only. Super easy. Actually, only the question was lengthy. Otherwise, the concept was very easy. On option D is the right answer. You have to, mostly the question involved the distance formula. Okay. Next is question number 7. Let y is equal to yx is the solution to the differential equation curve given by this differential equation. And you have y is x is greater than 0, and y is equal to 3 by 2 when x is equal to 4. And the slope of the curve is never 0. Then the value of y10 is. All right. Let's write down the equation, differential equation. This x square minus 4 dy minus y square minus this dx is equal to 0. or you will have dy is equal to this. Now it's easy, no? See, always if you're getting confused, make the sum in a simpler way. You won't, the main important thing is don't do silly mistakes in like taking out the terms on the right and the left hand side so that the whole sum will be wrong. Okay, so now this will be dy by y square minus 3y is equal to dx upon x square minus 2 square. Okay, now that is equal to integrating both sides. You have 1 upon y square, I'm taking this common, into dy is equal to 1 upon x square minus a square into dx. So this will be equal to, can I write it like this? Y minus y3, let's take this outside, upon this dy is equal to 1 upon, let's integrate now, don't write it. So dy is equal to, this is equal to natural log of, not a square, it was 2 square. This will be x minus 2 upon x plus 2, and that was 4, right? 2 square is 4, so 1 upon 2 square, which is equal to 4 plus c, right? So this is, let's open it. You have y upon y minus this, minus 1 by 3, y by 3, y minus 3 dy is equal to this plus c, right? Now the sum is very easy, right? This will be equal to y and y will cancel, and here this and this will cancel. So this will be 1 by 3 log of y minus 3 minus 1 by 3 log y is equal to 1 by 4 log x minus 2 x plus 2 plus c 1 by 3. I'm combining both of them. Log y minus 3 upon y is equal to this. Right. Now I want to find out this c. For that, I am given the question that x is equal to 4, y is equal to 3 by 2. Now at this. So you have natural log. Let's fill in the value. Y is equal to 3 by 2 minus 3 upon 3 by 2 minus is equal to x is equal to 4. So this will be 2 upon 6 plus c, 1 by 4. 1 by 3. Now I'm just solving it over here. Minus 3. This will be 3 minus wait. Yeah, okay. 3 minus 3 by 2. That will be 6 upon 2, which is minus 3 by 2. So that will be equal to minus 1. Or log of mod of minus 1, right, is equal to this 1 by 3 plus c. That's equal to 0. So that makes c is equal to, this is equal to 0, right? That makes c is equal to 1 by 3 minus log of this. Now that's equal to 1 by 4 log of 3 raised to power minus 1, right? And I'm taking this minus 1 also over here, minus 1. That is equal to 3. Okay, there's no need of mod actually. So you got the value of c. Let's fill in this value in this equation number 1. So from 1, you have 1 by 3 log of y minus 3 upon y is equal to 1 by 4 log of x minus 2 upon x plus 2 plus 1 by 3 log of 3. Now what you had to find out was, let's see once what you had to find out. It gives y, okay, you have to find out y10. That means you have to find out the value of y for which x is equal to 10. Okay, so this upon this is equal to this. Now, if I put x is equal to 10, this will be 8 upon 12 plus, this can be seen as 3 log 3 power 1 by 4. Right. Okay. Let it be like this only for the time being. 1/2 plus this. Okay. So you have over here, this will be equal to 1/3 log this on this. I forgot to write down log. This is log 2/3 raised to power 1/4 plus log 3 raised to power 1/4. Right? 1/4 both sides, no? Yes. No, they are in the plus. I'll multiply them. This will be log 2/3 power 1/4 multiply 3 power 1/4. This will give me log 2 power 1/4. Right? Hope everything is clear till here. Natural log y minus 3 upon y. So you have log of y minus 3 upon y is equal to 3 log 2 power this, which is equal to log 2 power 3/4. And this is equal to log y minus 3 upon y, or this is y minus 3 upon y is equal to this. Let's solve it further. This is equal to, we are not done now, till now. This is y minus 3. Now that's equal to 8. Yeah, 8 power 1/4 is equal to y into 8 power 1/4. Or let's bring this over here. Y minus y into 8 power 1/4 is equal to 3, or I'm taking y common. This is 8. See, one thing that was left over here, I removed this mod sign. There has to be some additions. In the question, it is given that for x is greater than 2, the slope is never 0. That means for when x is greater than 2, for all x greater than 2, dy by dx, it's decreasing, it's less than 0. And you are also given that y4 is equal to 3/2. That means y belongs in the interval 0 to 3, right? So here, this value, when I will open this mode, this will be taken as this. I'll be taking the negative value for this. All right. So this will be minus, and here will be the step. This one I'll rewrite. So this will be minus y plus 3 is equal to y into this. Or you have a 3 is equal to y into 8 power 1/4 plus y. Let's take y common, 1 plus 8 power 1/4. Or you have y as 3 upon this. This is the value for y when you have x as 10. Hope you're clear with this. Now let's check with the options. Was a lengthy one. This one first. Option A. Hope you're clear with this. Next is question number 18. Let E1 be the eccentricity of the given hyperbola, and the E2, this is the given hyperbola. Let's write it first. And here you have A as 4, B is 3. Okay. Now, this is having the eccentricity E1. This is the second one, ellipse, given by this equation. A is greater than B, that means this is horizontal ellipse. All right, now this is having the eccentricity E2, which passes through the foci of the hyperbola. E1 into E2 is equal to 1. Then the length of the chord of the ellipse parallel to the x-axis passing through 0, 2 is. First of all, let's come till here. Okay. You are given, we are not given, we are just given the equation of the hyperbola. And the chord, or the length of the chord you have to find out, which is parallel to x-axis and is passing through this point. First of all, let's get to our hyperbola. I'll find out E1. You know that is equal to C upon A, or this is a hyperbola. So centricity is given by the formula of 1 plus B square upon A square. Here the B is, we just solved, it was 3A is 4. So 1 plus 3 square upon 4 square, that is equal to 5 upon 4. That's your E1. Also in the question, you are given E1 into E2 is equal to 1. So that makes E2 is equal to 1 upon E1. That makes this is equal to 4 by 5, right? So, you know that is equal to C upon A. So you have C as 4 and A as 5 for the ellipse. This is for ellipse and this was your hyperbola. Now for the ellipse, I have A, let's calculate B also. For the ellipse, you have that C square is equal to A square minus B square. This is 4 square, A square is this minus this, B square is equal to 24 minus 16. So B will be equal to 3 in this case. Okay. For the ellipse, let's write down, you got the value of A as 5, B as 3, C is 4. What will be the equation of the ellipse? It's given x upon a square, y upon b square. So x upon 25 square plus y upon y square upon 9 is equal to 1. Now, we are done till here. Let's start. Then the length of the chord of the ellipse parallel to the x-axis and passes through this point. So this is your ellipse. That's your ellipse. This is your A5. Okay. And this is your 3. What do you have to find out? Okay, let's write down to be clumsy. This is your ellipse and this is your chord, which is passing through the point. What point? 0, 2. Okay. So this is your point 0, 2. These are the 2 points where it is cutting the ellipse. The equation of the ellipse we just solved, that's x square upon 25, y square upon 9 is equal to 1. Let's find out the A, these 2 points. These 2 points. So here x square upon 25. See, if y is equal to 2 over here, then y will be 2 at these 2 points also. So let's fill in y's value. 2 square, this is 4 upon 9 is equal to 1. X square upon 25 is equal to 1 minus 4 by 9. That's equal to 5 by 9, or x is equal to, x square is equal to 5 into 25 upon 9, or you have x is equal to root of this, which will be plus minus 5 root 5 upon 3. So the 2 points where it is cutting the ellipse, this is minus 5 root 5 upon 3. Here is this. Okay. What you have to find out was length of the chord of the ellipse parallel to x-axis. So basically I have to find out, if let's say this is point A and this is point B, you have to find out AB. So easy now. This will be 5 root 5 upon 3 plus 5 root 5 upon 3 square 2 minus 2 square, which will be 5 twice. Now 2 into 5 root 5 upon 3 whole square under the root. Okay, so this will give me 10 root 5 upon 3. This is the answer to the question. That makes C as the correct answer. Hope you're clear with this. Let's move to the next question, number 19. Let alpha be given by this equation and beta be this. Then you have to find out that alpha and beta. Alpha belongs to natural and beta doesn't. Okay, basically I want to know the nature of alpha and beta now. Let's go for that. First of all, let's write down, you have alpha is 4 factorial upon 4 factorial par 3 factorial, and you have beta as 5 factorial upon 5 factorial par 4 factorial. is 4 factorial is 24 factorial upon, I'll write it like this only. What is 3 factorial? 6. And from here, beta 5 factorial is 120 factorial upon 5 factorial raised to power. What is this? 4 factorial, that's 24. Now, let 24 distinct objects are divided in 6 groups of 4 groups each. 4 objects in each group. Let 24 distinct objects are divided into 6 groups of 4 objects in each group. Therefore, number of ways of formation of group will be of formation of group will be given by 24 factorial divided by 4 factorial power 6. Yeah, into 6 factorial. So this will give me some value which of course belongs to natural number. Similarly, let's look over here. Let 120 distinct objects are divided into, see here was 6 now, 6 groups, here is 24, are divided into 24 groups of 5 objects in each. So the number of formation of groups will be number of formation of groups will be given by 120 factorial divided by 5 factorial. It was raised to by 24, right? Multiplied by this. This again belong to natural numbers. So that makes which option is the correct answer? Let's check. Third one. C option is the right answer to the question. Hope you're clear with this one. Next question. Question number 20. Let the position vectors of the vertices A, B, C of the triangle given by these 3 vectors respectively L1, L2, L3 be the length of the perpendiculars drawn from the orthocenter of the triangle on the sides ABC respectively. AB, BC, CA respectively. You have to find out this expression. Let's make this triangle. These are having vertices ABC. So A is having 2, 2, 1. B is 1, 2, 2, and C is 2, 1, and 2. Let's look at the triangle. Let's try to find out the nature of the triangle. AB is given by root of 2 minus 1 square, 2 minus 2 square, 1 minus 2 square, which is equal to 1, 1 plus 1, right? Yeah, that's root of 2. And let's see BC. BC is again given by this 1 minus 2 square, 2 minus 1 square, 2 minus 2 square. Again, you have root 2. And let's find out CA or AC. I'm just looking at the length, so don't worry with the directions. Okay, this is 2 minus 2, 2 minus 1, 1 minus 2. Again, you have root 2. See, the 3 sides are equal, then bingo, we have a equilateral triangle. It makes things so easy for us. Is an equilateral triangle, therefore orthocenter will be equivalent to your centroid. Let's make the orthocenter. So this is the point 1, 2, and 3. Okay, don't go on the line, it's all right. So this is your orthocenter as well as your centroid. Now, if I take the point D, that means D is the midpoint on AB because this G was your centroid. ABC is an equilateral triangle. Now, midpoint of AB is equivalent to D. Let's find out D. That will be 2 plus 1 upon 2. Then 2 plus 2 upon 2. Then 1 plus 2 upon 2. This will be 3 by 2, 2, 3 by 2. Okay. Yeah. This will be D. Okay. So we got these coordinates and let's write it. What was it? It was 3 by 2, 2, 3 by 2. Okay, let's find out the G's coordinates now. Also, this is G. This is the centroid. So the centroid will have that will be coordinates of x coordinate of A plus B plus C divided by 3. For the Y, it will be Y coordinate of A plus B plus C by 3. And for the Z, it will be this and this and this by 3. Let's write it down. You have 2 plus 1 plus 2 upon 3. Then you have 2 plus 2 plus 1 upon 3. Then you have 1 plus 2 plus 2 upon 3. This will be equal to 5 upon 3, 5 upon 3 and 5 upon 3. This is your G and we just calculated D as this. Okay. Now, let's say what is in the question? L1, L2, L3. They are the length of perpendiculars drawn from the orthocenter of the triangle on the sides. So on AB, it is L1. This is L2. And for this is L3. BC is L2. And this is L3 for AC. Right. Now let's calculate. So sorry, I just erased everything. Please rewind the video because I have to solve the whole sum again. I'm recapturing the sum from here. This was your triangle. And this was your point A, which had the coordinates or direction ratios as this. B has 1, 2, 2. And that was your C. The point was 2, 1, 2. And this, and this. This was your point G. This was your point D. This was your L1. This was your L2. And this was your L3. Now, G had the coordinates. You can rewind the video and watch it again. 5 by 3, 5 by 3, and 5 by 3. These coordinates we calculated, they came out to be 3 by 2, 2, this. Okay. Now, you have to find out GD. What is L1? L1 is nothing but GD. Now, GD is what? Distance formula. So many questions on distance formula you have got. 5 by 3 minus this square. 5 by 3 minus 2 square. 5 by 3 minus 3 by 2 square. This will be equal to root of 6. This will be 10 minus 9 square. 5 minus 6, 3 square, and the same thing. So this will give me 1 by 36, 1 by 9, 1 by 36. When you will solve this whole thing, you will get 1 by root 6 only. So similarly, see, this is a nice equilateral triangle, right? ABC equilateral triangle. So L1 will be equal to L2 will be equal to L3. So you have this as root 1 by 6. What do you have to find out in the question? To find L1 square, L2 square, and L3 square. Right. So this will be 1 by 6 plus 1 by 6 plus 1 by 6, which will be 1 by 2. 3 by 6, that is 1 by 2. So this is the answer to the question 1 by 2, option B. Hope you're clear with this. Let's move to the next question. Question number 21. The mean and standard deviation of 15 observations was found to be 12 and 3 respectively. So the mean is 12, standard deviation is 3 respectively. On rechecking, it was found observation was read as 10 in place of 12. If mu and sigma square denote this mean and variance of the correct observations respectively, you have to find out the value of this expression. Okay, so basically nothing. You have to find out. The whole question revolves around mean and the standard deviation. Okay, let's go. First thing, let the incorrect mean be mu. It's given mu and sigma square denote the mean and variance of the correct observations. Okay. Then I'll take it as mu dash. Now, and the incorrect standard deviation as sigma dash. Okay. Now, according to the question, you have mu dash is equal to sigma xi. 15, total 15 observations were there. So divided by 15. In the question, it is given that it was 12. And also your sigma dash is equal to 3. Okay. So you have mu dash as 12, or from here you have sigma I is equal to 12 into 15, which is 180. Now, as per the correct information, as per correct data, what should sigma xi be? See, it was read as 10 in place of 12. So this is the correct and this is the incorrect observation. So I will subtract this 10 and add that 12. This will be equal to 182. Okay. So now, what will be the correct mean? This is the formula. This is 182 upon 15. That is equal to something. So it will be, let's divide it. 182, 15. This will be 1, 2. So this will be this. 12, 2 upon 15. This is the answer. This is the correct mean. This is first answer. Mu. Okay. Now in the question, you are given that the incorrect variance is equal to 3. What is the formula for that? That is equal to sigma xi square upon 15 minus sigma xi upon 15 whole square. So this is equal to, this is for the incorrect one. So this is equal to summation, that's equal to 3 summation xi square upon 15. That was 180 upon 15. This is the one, and this gives you 12. This is summation xi square upon this minus 144 is equal to, I'll remove this. This will be 9. Or you have summation xi square upon this is equal to, this is equal to 153. So summation xi square will be 153 into 15, which is equal to 2295. Now, this was this. What will be the correct summation xi square? Again, see, this is the incorrect one. I have to subtract the square of 10 and add the square of 12. This will, on solving, give me 2295 minus 100 plus 144. That will be 2339. So sigma square, which is your correct variance, first of all, is given by 2339 upon 15 minus 185 into 180, no, 82, sorry. 182 into 182 upon 15 into 15. Hope you remember the formula. This is summation xi square upon n minus summation xi upon n whole square. So this is equal to, this is, what do you have to find out? Wait, was this? Okay, let's solve this. This will be equal to 15. Let's do the calculations. Give me a minute. We'll do the calculations later. It will, I'm just using this formula, 15 mu plus mu square plus sigma square to find was 15 mu plus mu square plus sigma square. This is 15. What was your mu? That was 182 upon 15. and mu square will be equal to 182 into 182 upon 15 into 15 and summation square. This is equal to minus 2339 upon this plus 182 into 182 upon 15 into 15. Now, I hope you understood like why I didn't do the calculations at that point. So tough things, they got eliminated by themselves. So this will be 15 will be taken LCM 182 minus wait. I did a mistake. Here was plus and here was minus. Okay. So this is this. This will give me 15 and 15 will also cancel. This will be 1, 4, 5 and 2. 2, 5. 2, 5, 2, 1, not 4, 2. Yeah. Okay. So 2, 5, 2, 1. This is the answer to the question. Hope you're clear with this. Let's move to the next question. Question number 22, if the area of the region given by xy such that y belongs is within the limit 0 to minimum of these two functions is a, then what is the value of 12? Basically, you have to find out a, right? For solving the problem, first of all, you need the area and the best thing to do, plot a graph. So y lies between 0. Okay, y lies between 0, 0 is on this line. So this is the line y is equal to 0 and minimum of 2x and this. First of all, this is the line y is equal to 2x. This is the line. And then you have 6x square minus x. This can be written as I'm taking x common, 6 minus x is equal to 0 for finding out the coordinates. So that means x either can be equal to 0 or x can be equal to 6. So this is a parabola. This is a downward parabola like this, which is passing through the origin like this. Okay, let's make it more proper. Wait. So this parabola is something like this. Okay. Yeah. Now this is the point 6, 0, and this is the origin. Both line and the parabola, they are intersecting at this point. First of all, this and this is the second point of the intersection. Now you have to find out the area of this given region according to the question. X lies between 0, y lies between 0 and the minimum of these functions. So you have to find out the area of this particular region. Right, let's go for this. First of all, this area, I will divide this area in two halves. This is the one. Now, this is a triangle. And this is your area of the region. This is your region, which is between the x-axis and the given parabola. So these are the two ways in which you can calculate the area. I need to find out the point of intersection, this point. I need to find out this point. So you have this equation and 2x, point of intersection of 2x and 6x minus x square. So that means 2x will be equal to 6x minus x square, or you will have 4x minus x square is equal to 0, x4 minus x is equal to 0, x can be equal to 0, x can be equal to 4. For this, y will be equal to, this will be the point. For, this will be the point, origin. Y will be 0 and for x is equal to 4, you will have y is equal to 8. So the point of intersection is 4, 8. Okay, so this particular point is 4, 0. Now you have to find out the area of this triangle. Let's say this is region 1 and let's say this is your region 2. Okay, now required area A is equal to area of region 1 plus area of region 2. This is your triangle, half into base into height. And this is your parabola. From the limits, it will be from 4 to 6. 4 to 6, 6x minus x square dx. Base, what is base? How much is base? This base is from 0 to 4. This base is 4 and the height is given by 8. So this is half into 4 into 8 plus limits 4 to 6. This will be 6x minus dx. Dx minus 4 to 6 x square dx. That will be equal to 16 plus this will be 6x square upon 2 limits this minus x cube upon 3 limits this. So you will have here, this will be 16 plus 3x squared, 3 I'm taking outside, 4 and 6 minus, this will be 3 again, I have taken this outside, x cube, 426. This will be 16 plus 3, 36 minus 16 minus, this will be 1 by 3 into 6 cube, that will be 216 minus 64. So this will be equal to 16 plus 3 into 20, which is equal to 60 minus, this will be 216 minus this, 251 upon 3. So let's take, this is 76 minus upon this. So this is equal to 3, and this will be 8 and 22 minus 152. This will be 6, 7 upon 3. Okay, 76 upon 3. This is the answer to the question. But okay, we have to find out 12a. So what will be 12a? Multiply by 4. That will be 304. So the answer to the question, 304. This is the right answer. Hope you got that. Next is question number 23. Students, before starting the question, is a quick reminder to visit our website, www.examsnet.com. This is a great place for you to practice all your entrance exam question papers. Here you will find all the papers with their detailed PDF solutions. For a better preparation, must download our app. The link is available in the description box. So let's start with the next matrices problem. Here you're having A is a matrix, 2 by 2 real matrix, I is the identity matrix, again, order 2. Root of the equation, these are minus 1 and 3. You have to find the sum of the diagonal elements of a square. Okay, so you have this equation and the roots are minus 1 and 3. So in a matrix such as this one, sum of roots is that's given by the trace of A. And in this case, it's minus 1 plus 3. That's equal to 2. Also, the product of the roots is equal to the determinant of the matrix, which is equal to minus 3 in this case. Now, let's say A is A, B, C, D. So according to this, what is trace of A? It is sum of the diagonals, diagonal elements, trace of A plus D, which is equal to 2. Okay. Also, determinant of A, it is given by AD minus BC. In this case, this is equal to minus 3. Let's find out A square, A, B, C, D, A, B, C, D. That's equal to A square. This here will be AC plus CD and BC plus D square. Okay. And what we need is the sum of the diagonal elements of A square is. I need to find out the sum of these two elements. Sum of diagonal elements is A square plus BC, which is 2BC plus D square, right? Now in the question, according to the question, we have okay, this is I need to find out. I already have these two equations where, okay, these are the two equations. Let's pick them up. So I can write down this equation as A square plus D square plus 2BC, or this can be written as A plus D whole square minus 2AD plus BC, 2BC. This is equal to 2. So that gives me 4 minus 2AD. Wait. I will take minus 2 outside. This will be AD minus BC. And AD minus BC was equal to minus 3. So this gives me 10. Answer to the question, 10. Hope you're clear. Next is question number 24. If the sum of squares of Okay. The sum of square of all real values of alpha for which these three lines do not form a triangle is P. The greatest integer, then the greatest integer less than or equal to P is. All right. You have these three equations. 2x minus this plus this is equal to 0. 6x plus this and alpha x 2y minus 2 is equal to 0. So you are given that they do not form a triangle if the sum of square of all values of alpha for which these three lines do not form a triangle is P. So sum of squares of all values of alpha is equal to P. Okay, now they don't form a triangle. What are the conditions for that? That means there are two things. Either one of the lines, this line is congruent with these lines. It is either congruent with these lines obviously or parallel with these lines. This line will be either congruent, that is on the same, like on the same line, or they will be parallel lines. Then only they will not form a triangle. Otherwise they will, because if they are having any angle, they will surely form a triangle. Correct. Now, first case, if I consider they are the congruent lines. What are the conditions for that? Determinant of the lines is equal to 0. What will be the determinant? 2 minus 1, 3, 6, 3, 1, alpha 2 minus 2. This determinant is equal to 0. Or this will be 2 into minus 6 minus 2 plus 1, 12 minus 3 alpha plus 3, 12. No, sorry, I did a mistake. Okay, let's write it again. 2 into minus 6 minus 3 plus 1 into minus 12 minus alpha and plus 3, 12 minus 3 alpha is equal to 0. Minus 18 minus 12 minus alpha plus 36 minus 9 alpha is equal to 0. So this is 36 minus 10 alpha is equal to 0. Or you have alpha is equal to 6 by 10. There is a mistake. This was supposed to be 6 minus 2. So this one was 2 and it will be 16 and it will be 8. All right. Alpha will be 8 by 10 or 4 by 5. Okay. So now this is one of the values of alpha. And now the second case, if the lines are parallel. For the lines to be parallel, you know the condition is A1 upon A2 is equal to, or you say A1 upon B1 is equal to A2 upon B2, right? And that's not equal to C1 upon C2. From here, if I pick up these two lines, you have alpha upon 6 is equal to 2 by 3. Alpha upon 6 is equal to 2 by 3, right? So now this will be modulus. I'll be taking the modulus. Why? Because I don't know whether the alpha is positive or negative. Nothing is such thing is given to us. So alpha will be equal to, this will give me like this, will cut at 2. Alpha will be equal to plus minus 4. So the three values, let's say this is equal to 2. Alpha is equal to 4 by 5, or this is equal to plus 4, or this is equal to minus 4. Now, according to the question, P was sum of squares of all real values of alpha. So this is equal to this square. P is equal to 4 square minus 4 square 16 upon 25 plus 4 square 32. All right. Let's solve this. And before solving in the question, you are given greatest integer less than or equal to P is. So the greatest integer less than or equal, this is less than 1. This value is less than 1. So the greatest integer less than or equal to P will be equal to 32 only. Answer to the question 32. Hope you are clear. Next is question number 25. Question number 25, the coefficient of x bar 2012 in the expansion of this whole expression is equal to. Let's write down the expression. You have 1 minus x bar this, 1 plus x square bar this. To make the bars equal, I'll write it as 1 minus x bar 2007 into this expression. So powers are same, bases will multiply. This will be 1 minus x into 1 plus x square power 2007 is equal to 1 minus x. This will be 1 plus x square minus x square minus x cube power 2007. They will be cut down and you will have a 1 minus x cube part 2007. So let's expand this. That'll be 1 minus x into 2007 C0 minus 2007 C1 into x cube, so on. So here the general term will be given by 1 minus x into 1 minus 1 raised to power r into 2007 CR x bar 3r. Okay. Right. So let's do the multiplication now. This will be 1. Rather, this will be, I'll open up the bracket. So this will be 1 multiplied by this whole thing. So this is minus 1 power r multiplied 2007 CR into x bar 3r minus 1 r into 2007 CR into x bar 3. Here this x will be multiplied, so 3r plus 1. Okay. Right. Now what you need to find out is the coefficient of x bar 2012. So here either this may be or this may be equal to 2012. So either this is equal to 3012 or this is equal to x bar 2012. So from here you have 3r as this. R can't be equal to this value because this is not integer value. Let's try this. 3r plus 1 is equal to this. Or you have 3r is equal to 2011. Or r will be equal to 6. This is again not an integer. R is not an integer because this is equal to 6. Then again 701 by 3. This is not an integer. So both of them do not have an integer. That means there is no term which is containing x raised to power this 2012. There is no term which contains this. That means the coefficient is equal to 0. This is the answer to the question. Hope you are clear with this. Next is question number 26. Question number 26 is the solution curve of this differential equation passing through this point is given by this equation. Then you have to find out 5 beta plus alpha. Here is your beta and here is your alpha. Basically, you have to solve the differential equation. Let's write down. You have dy by dx is equal to x plus y minus 2 upon x minus y. Let's put x is equal to x plus h and y is equal to y plus k. So that means this equation now can be written as dy by dx is equal to this, right? Here your h plus k minus 2 will be equal to 0 from the numerator. And so if you put x is equal to x plus h and x plus h plus y minus plus k minus 2. So that means h plus k minus 2. This should be equal to 0. Similarly, from here, from the denominator, x plus h minus y minus k should be, from here, h minus k should be equal to 0. So these are the two equations. From both of them, you will have h should be equal to k should be equal to 1. Now let's put y is equal to vx. Let's differentiate it. First of all, before differentiating, I'll put this in this equation. You will have dy by dx is equal to x plus vx upon x minus vx. This will be x taking common 1 plus v, 1 minus v. This is equal to this. So you have dy by dx is equal to this. Now let's use this equation again. Let's differentiate. Dy by dx is equal to first function into this plus second function into derivative of first. So you have, this is already solved. Let's fill in this equation. 1 plus v upon 1 minus v is equal to v plus x into dv by dx. Let's take the things on left hand side. So this will be x into dv by dx is equal to 1 plus v upon 1 minus v minus v. This will be 1 plus v minus v plus v square divided by 1 minus v. So this will be 1 plus v square divided by 1 minus v. This is x into this function, right? Let's do integration on both sides. First of all, I'll write it over here. So, okay, first of all, let's take v over here. This will be given by this is dx. So this will be dv into 1 minus v upon 1 plus v square is equal to this. Or this is equal to dx upon x is equal to 1 minus v upon 1 plus v square into dv. Let's integrate both the sides now. You will have tangent inverse v minus half log 1 plus v square is equal to log x plus c. Now to find out the value of the c, you are given that this point passes through the point 2, 1. For the point 2, 1, you will have, let's fill in the value of this v, tangent inverse v. So v was equal to y upon x minus half log 1 plus y square upon x square is equal to log of x plus c. Now we have written, we knew one thing that, what was it? Small y is equal to capital plus k. So we had small y is equal to capital plus k. K was equal to 1. So y minus 1 is equal to capital Y. Similarly, small x minus 1 is equal to x. Let's fill these things in this equation. So you will have tangent inverse y was equal to y minus 1, x minus 1 minus half log. This will be 1 plus y minus 1 square, x minus 1 square is equal to log x minus 1 plus c. This is under the mod. Even this is under the mod. All right. So now for the point 2, 1, let's fill in 2, 1. This will be tangent inverse 0. That is 0 minus half log of, again, you will have a log 1. This is equal to log of 1 plus c. So that makes, I think, 0. C is equal to 0. So now this equation becomes tangent inverse y minus 1, x minus 1 minus half log y plus 1 plus this upon this is equal to log x minus 1. That's it. Okay. Yeah. So let's compare it with the given equation. What was that? Let me see. What is that equation? That was tangent inverse this minus 1 upon beta log e, natural log, that's same thing, alpha plus y minus 1 square x minus 1 square log x minus 1. So that means beta is equal to 2 and alpha is equal to 1. So easy, right? After so much of work, you got so simple values. You have to find out 5 beta plus alpha. So 5 beta plus alpha gives you 11. Simple as that, right? Is the answer to the question. Answer is 11. Hope you're clear. Next is question number 20. Question number 27, let fx be given by this function, integral of 0 to x gt log this function, where g is the continuous odd function. And if this integral is equal to this value, then what is the value for alpha? All right. So first thing, see, I am given fx is equal to integral 0 to x gt log of 1 minus t upon 1 plus t. If I consider only this function, let's see over here, you have two functions in this case, gt and log of 1 minus t upon 1 plus t. You are given this is odd function, right? This is odd. And let's check how this function. Actually, this is also odd. I'll just show you how this is odd. Let you have any u function. Ux is equal to log of 1 minus x upon 1 plus x. So what will be u of minus x? This will be equal to log of, this will be like 1 plus x upon 1 minus x. This is nothing but log of 1 minus x upon 1 plus x raised to power minus 1, or this will be equal to minus log of 1 minus x upon 1 plus x, which is nothing but minus u of x. Right? So u of minus x is equal to minus this. That makes this function also to be odd. So both of these functions, they are odd, right? Okay. Now this is also an odd function and this is odd function. Both are odd function. Let's do differentiating both sides. Differentiating both sides. You have f dash x is equal to gt into log of 1 minus t upon 1 plus t. So this was odd, this was odd. That makes f dash x to be an even function, because odd into odd, it gives you even. If the derivative is an even function, that gives you the function to be odd. I'm repeating, this becomes odd into odd. That means the f dash x odd into odd, you always know this is an even function. So because minus minus, they will cancel out each other. This will be an even function. And if the derivative is 0, the function itself will be odd. All right, done. That means this is an odd function. Let's keep it out. I'll come to this equation now. You are given in the question, let's write down, given integral minus pi by 2 to pi by 2 fx plus x square cos x upon 1 plus e raised to power x dx. See, this is an odd function. No need to solve. This will evaluate to be 0 only. Okay, integral will come out to be 0 only for the odd functions. Correct? So, for these limits, so it will be reduced to this thing. Okay. Now, what will I do? Over here, I wanted to tell you one thing. I have used the Leibniz rule. So now, okay, I'll be using King's rule over here. This is a very good rule, right? So this will give me minus pi by 2 pi by 2. See, what is the rule that I hope you know that if limits a to b, f x dx is equal to limits a to b, this is equal to a plus b minus x dx. So this makes a minus pi by 2 pi by 2 minus x whole square into cos minus pi by 2 plus pi by 2 minus x divided by 1 plus e raised to power minus pi by 2 plus pi by 2 minus x dx. Okay, obviously they will cancel out, and this will be minus pi by 2 to pi by 2 minus x squared. This will be x squared. Cos minus x will give you this, and this will be this dx. This is minus pi by 2 e raised to power x into x squared into cos x upon 1 plus e raised to power x into dx. Okay, that was, let's say, your I. Let's say this is 2 and this is 1. That was also I. So you will get 2i is equal to limits minus pi by 2 to pi by 2 square cos x plus x square e power x cos x divided by this dx. Or this will, like, I'll take common. One thing more I'm doing, and this is okay, leave it, I'll do it later. So this one taking x square cos x 1 plus e power x plus this, they will cancel dx. Now you're left with minus pi by 2 to pi by 2 x square cos x dx. Now this is an even function also. This is an even function. Both are even functions. So that means I can change the limits. This will be equal to one thing that, okay, that was equal to 2i, that is 0 to pi by 2. 2 will be taken outside. X square cos x dx. This 2 and this 2 will cancel. I will be equal to integral limit 0 to pi by 2 x square cos x dx. I'll be using integration by parts to solve this. This will be x square into integral of this sin x. Yes. Limits this minus integral of 2x sin x dx. So this will be giving me pi square by 4 sin pi by 2. This is equal to 1 minus 0. Minus 2 I'm taking outside. Integral of x sin x. Now again I have to use integration by parts. The limits were 0 to pi by 2. So now this will be this 0 to pi by 2. I'll be solving, wait. Okay, so this will give me minus x, because the integral of this sin x will be minus cos x plus integral of 1 into cos x dx. This will be 0 to pi by 2. Here also. Okay, this will give me pi square by 4 minus 2 minus pi by 2. Okay, this will be 0 only, and this will be 0. Okay, both will be 0. And here you will have a cos x integral, that's this. This will give me pi square by 4 minus, this 2 was with this also, right? Here also. Minus 2 into 1. So this is pi upon 2 whole square minus 2. Let's compare it with the given equation, which was this pi square upon alpha minus alpha. So this was equivalent to pi upon alpha whole square minus alpha. That gives me alpha is equal to 2. That's it. We needed that value only, right? I needed to have the value of alpha that's equal to 2. So this is the answer to the question. Hope you are clear with this. Let's move to the next question. Next is question number 28. You have consider a circle x plus alpha whole square y minus beta whole square is equal to 0, where alpha and beta greater than 0. If the greater than 0, that means they are lying. Okay, fine. I'll talk about that later. If the circle touches this line at the point P, whose distance from the origin is given by this, then what is the value for alpha plus beta whole square? This is your circle. The center of the circle, according to this equation, x minus alpha square y minus beta square is equal to root 50 square, which is equal to 5 root 2 square. So this is your center, alpha and beta, and the radius 5 root. Okay. Now in the question, in this particular question, it says it touches this line, y plus x is equal to 0. So this is the line. If I say this is the coordinate axis, this is the line y minus x is y plus x is equal to 0. Yeah. Okay. So it touches this line. Okay, sorry, it touches this line. I have to remake this one. This is this. Now it touches this line. I'll draw the x's later. At the point P. Okay, now let's say this is your x, and let's make the y-axis from here. This is the correct figure. This is the x and the y, and you are given that this distance, it touches this circle. That means if I take this as r, this is the radius. This is O. OP is equal to radius is equal to r. All right. Also, you are given that the distance of the point P from the origin is 4 root 2. Let's take origin as something else, or let's take this as C. Okay, the point C. I'm taking the origin as point C, so CP is equal to 4 root 2. Okay, so now let's get back to our question. One thing, I have OP as radius, so this is equal to 5 root 2. I know the coordinates of O, that are alpha and beta. And this is the equation of the line, x plus y is equal to 0. So OP is perpendicular to line x plus y is equal to 0. Therefore, OP will be given by modulus of the coordinates of O are alpha and beta. And this is your P lies on this line, right? So that means alpha plus beta plus 0 divided by, this will be root of 1 square plus 1 square. This is equal to 4 root 2. Alpha plus beta upon root 2 is equal to 4 root 2. Let's do squaring on both the sides. You have alpha plus beta upon 2 whole square upon 2 is equal to 16 into 2, which is equal to 32. That gives you alpha plus beta whole square is equal to 64. Right? Sorry, that was 5 root 2. That's not 4 root 2. 5, 5. So 25 into this will be 50, and this will be 100. Okay, so that's it. I think this is what we needed. Alpha plus beta whole square. Yes, I needed that only, and this is equal to 100. Actually, very easy question that was. The only thing was you had to make a figure. Okay, let's move to the next question then. 29. The lines this and this intersect at the point P. If the distance P from this line is L, then what is the value of 14L square? You are given the two lines. Let's write on the first one. You have x minus 2 upon 2 is equal to y upon minus 2 is equal to z upon z minus 7 upon 16. Now this can be written as, I'm dividing all of them by 2. Okay, I'm like denominators. So this will be this is equal to this is equal to z minus 7 upon 8. Let's say that's equal to lambda. Also, let's pick up the second one. You have x plus 3 upon 4, y plus 2 upon 3 is equal to z plus 2 upon 1. Let's say that's equal to k. Right. So you get three things. First is, I'll pick up this one. X minus 2 upon 1 is equal to lambda. This will give me x. Okay, this is for the point of intersection. This will be x is equal to lambda plus 2. And from here, x will be equal to 4k minus 3. So that means for the point of intersection, lambda plus 2 is equal to 4k minus 3. Also, you will have minus lambda is equal to 3k minus 2. So let's combine both of them. Lambda is equal to 2 minus 3k. Let's fill in this equation. You will have a 2 minus 3k plus 2 is equal to 4k minus 3. Or you will have a 4 plus 7 is equal to 7k. That means k is equal to 1. And that means lambda will be equal to 2 minus 3 into 1, which is equal to minus 1. I have the value of lambda and k as this and this. Okay. So now the point of intersection will be, for the point of intersection, you have lambda is equal to minus 1, k is equal to 1. I can use either of these. The equation was x minus 2 upon 1 is equal to y minus 1 is equal to z minus 7 upon 8 is equal to minus 1. That gives me the value of x as x minus 2 as 1 minus 1 plus 2. So this is equal to 1. Y is equal to minus 1 into minus 1. Y is equal to 1. And Z is equal to minus 8 plus 7, which is equal to minus 1. So point of intersection P, point P of intersection, it is 1, 1, minus 1. That is the point of intersection. And now you need, if the distance of P from this line is L, I got the P, let's find out the distance of the point P, which is 1, 1, minus 1. This point distance from this line, which is, which was the line? Let's write it down. X plus 1 upon 2. X plus 1 upon 2. And y minus 1 upon 3. Z minus 1 upon 1. So what are the direction ratios for this? This line, if I'm writing the vector form, this will be 2i, 3j, and k. Okay, this is the vector form of the line. All right, now what you are asked that this distance is equal to L. Now projection of this vector. Let's say this one. This is the point. See any point on this line, it will be like minus 1, 1, and 1. Let's say this is Q and this is R. So projection of the vector PQ on this line 2i, 3j plus k. What will be the PQ vector? If I consider these 2 points, P and Q, PQ vector will be given by 2, it will be 1 minus of minus 1, I plus 1 minus 1 j plus minus 1 k. So this will be equal to 2i minus 2k vector. And projection of this, projection of 2i minus 2k on 2i 3j plus k. This is given by, this will be 2 into 2, 4 minus 2. 2 into 1, 2 divided by root of 2 square, 3 square, and 1 square. This will be 2 upon root 14. That is your L. Not that is not your L. This is, okay, sorry, this is the projection. Now I have to find out your L. So L square will be given by, here, this was your L, right? So L square will be given by, this is EQ square minus this square, this one, QR. Okay, so what is your PQ? PQ is the distance between the 2 points P and Q. P was your 1, 1 minus 1, and Q was minus 1, 1, and 1. So this will give me 2 square and 0 square and minus 2 square. This will be equal to root of 8, or PQ square will be equal to 8. Similarly, QR is equal to 2 by root of 14, and QR square will be the square of it. So this will be equal to 8 minus 4 upon 14. That will give me 2 and 112 minus this upon this. That's equal to 108 upon 14. And you had to find out that is your L square. I had to find out 14 L square, which is equal to 108. So this is the answer to the question, 108. Hope you're clear with this. Now let's move to the last question of this paper, question number 30, complex number. The only complex number problem we got in this paper. Let the complex numbers alpha and 1 upon alpha on these circles respectively, where z0 is 1 plus iota. You have to find out the value of 100 modulus alpha square is equal to. Okay, seems easy. Let's try. So you are having z minus z naught modulus square is equal to 4. That gives me, one formula that the modulus of any complex number is equal to the product of that complex number multiplied by its conjugate. So this can be written as, if I put these lie on this circle. So that means I can write it like alpha minus z naught into, first of all, I'll just write it like, I can write it like z into z naught minus z naught conjugate is equal to 4. Now I'll put z is equal to alpha. So z minus this multiply its conjugate minus z conjugate is equal to 4. Let's open it up. You have alpha into its conjugate minus alpha into z naught conjugate minus z naught into alpha conjugate plus z naught modulus square is equal to 4. So, already that's alpha square modulus minus, I'll do one thing. Okay, let's write it like this only. Alpha z naught this minus z naught alpha conjugate plus z naught. I know the z naught, right? So here is z naught, that is equal to 1 plus iota. So its conjugate will be equal to root of 1 square plus 1 square, which is equal to 2. So its square will be equal to 2 only. This will give me alpha this minus, here was plus z naught alpha conjugate is equal to 2. Okay, now let's say this is equation 1. The second one was, this is equal to 16 also. Okay, the second one is, now you also have z minus z naught square is equal to 16. That again gives you the same thing. Z minus z naught multiply by its conjugate is equal to 16. Let's put z is equal to 1 by alpha now. This is equal to 16. Right. Let's do the multiplication. You have 1 upon alpha into 1 upon alpha conjugate minus 1 upon alpha into z naught conjugate minus 1 upon alpha conjugate into z naught plus z naught into z naught conjugate is equal to 16. This is equal to 1 upon alpha square, modulus square, and here was minus this plus this, and this we already solved, right? That was it was root 2 square will be, here is square supposed to be. No, this will be z naught square. This is equal to 16. So you have 1 by alpha whole square minus 1 by alpha z naught conjugate, 1 by alpha conjugate z naught is equal to, that was 2. So this is equal to 14. Now let's multiply both the sides by alpha square. You will have 1 minus, here will be alpha square. So this will be alpha into z naught conjugate plus This will be alpha conjugate into Z naught. Yeah. This is equal to 14 alpha square. Right. This is, hope you're clear. Let's say this is equation 2 and this was your equation 1. So let's solve from both 1 and 2. Let's write down the first one also with it. You had alpha square conjugate is modulus is equal to, that was 2 minus alpha Z naught plus it was alpha naught Z this. I think it was this. Here was supposed to be plus because I have taken this on the right hand side. Okay. Now let's add both of them. You will get these two terms will cancel. This is equal to, here was equal to sign. So these two terms will cancel. You will have 3 is equal to 15 modulus of alpha square, or 1 is equal to 5 this, or you have, let's multiply both sides by 100. This is equal to 20. And that is what we needed in the question, right? That's equal to 20. So students, with that, we have completed all the 30 questions of this paper. Hope you understood them well, and do watch our other paper for the JEE mains as well. Students, don't forget to visit our website www.examsnet.com. Here you will find all the entrance exam question papers with the detailed PDF solutions. Also, you may download our app. The link is available in the description box. So students, keep shining, keep rising high. That's all for this paper. Our very best of luck. Bye.